Math with Miss Reimer. Today we're looking at section 1.7. The second part, we're looking at adding and subtracting scientific notation. This is going to feel a little bit familiar to the multiplying dividing section as well. So for this problem, you first need to make sure that the exponents are the same. You can't add or subtract scientific notation unless the exponents are the same. Think of it kind of like common denominators on a fraction. So in order to get exponents that are the same, we can use LARS again, left add, right subtract. It's going to be simplest for you to match the higher exponent, and you're basically going to be using the left add rule exclusively. We won't use the right subtract rule much. So then we're going to add and subtract the front numbers, and we will keep the common exponent. So similar to when you're working with fractions, you'll add the numerators but keep the denominators. Kind of same thing here. We'll add or subtract the front numbers but keep the common exponent. So for instance, in example 1, we already see that our exponents are the same. So because our exponents are the same, we can go ahead and just add the front numbers because that's our operation here to get 8.6. And then we'll just still keep it times 10 to the second power because our powers already match, and then we're good to roll. So in number 5, right now we see that we have a 7 and a 6. So what I want to do is I want to take this 6 and I want to add 1 to it so that it becomes a 7. And if I add 1, then I need to move the decimal to the left once. So this problem becomes, the first set of scientific notation doesn't change, but the second one becomes 0.11 times 10 to the 7th. Now my exponents are the same, so now I can take my front numbers and add those together and then carry the power that is the same, and then I already have a number that is in final scientific notation form. Notice that this number stays in between 1 and 10 because I matched the higher exponent. In number 3, we have -4 and -5. So because -4 is the larger exponent, I want to match that one. So I'm going to add 1 to the 5, which forces me to move the decimal point to the left. So this becomes 0.318 times 10 to the -4th. And then my first power and scientific notation doesn't change. So now I need to add the front numbers. And then my power will stay the same. So when we add these two together, we'll get 7.558 times 10 to the -4th. This is already between 1 and 10, so it's already in scientific notation form as its own. In number 4, when we look at the powers first, -3 and -2. -2 is the larger one, so I want to match that. So I'm going to add 1 to the -3, which means I have to move my decimal to the left once. So we'll take 0.68 times 10 to the -2nd plus the 2.7 times 10 to the -2nd doesn't change. And then we will take our front numbers and we will add those two, which will give us 3.38 times 10 to the -2nd. We'll keep the power, and this is already in proper form in between 1 and 10. In number 5, look at your powers first. We have 7 and 8, so we want to match the 7 to the 8, so we're going to add 1, move the decimal to the left to give me 0.42 times 10 to the 8th. First piece stays the same. And then because our powers are the same, we will add the front numbers. And so that will leave us with 2.96, which is in between 1 and 10, times 10 to the 8th. In number 6, we now have subtraction, and we can see that our powers are the same right now. So because of that, I get to jump right to subtracting the front numbers, which will leave me with 5.57, and then still times 10 to the 4th, because my power is already in common. In number 7, we've got a -2 and a -3 on our powers, and so -2 is the larger, so I want to match -3 to it. If I add 1 to the exponent, I have to move my decimal place over 1. So this one doesn't change, but the second one becomes 0.232 times 10 to the -2nd. And then we will subtract the front numbers. which will give me 7.358 times 10 to the negative second. In number 8, again, look at our powers. I've got a 13 and an 11. So I want to match the larger power, so I'm going to add 2, which means I have to move this decimal over 2 times. So this becomes 0.093 times 10 to the 13th. And then my first scientific notation stays the same. Now I have matching powers, so I can subtract my front numbers, which will leave me with 4.927 times 10 to the 13th. So that means the negative 6 is larger, so we'll add 1 to the negative 7, which means I have to move the decimal place 1 to the left. My first piece doesn't change at all. And now I can subtract my front numbers. And when I subtract my front numbers, I will get 3.54 times 10 to the negative 6. Let's say, for instance, that you got these mixed up and you matched to the negative 7 instead of the negative 6. Your answer will still come out the same. The only thing that's different is you would have gotten 35.4 times 10 to the negative 7th, and then you would have had to go back and convert it to formal scientific notation form. You still would end up with the same answer by the time you're done. So in number 10, we need to match to the larger exponent. So that means we're going to match to the negative 1. So we'll add 1 to the negative 2 and move the the decimal over. So that will leave me with 0.27 times 10 to the negative 1 minus 5.3 still over here. And now I can subtract my front numbers. And when I do that, I will be left with 5.03 times 10 to the negative 1. That's all today for Math with Miss Reimer. Don't forget the 5 things. You are lovable, valuable, changeable, forgivable, and never alone. I hope you're confident in the math. I hope you feel like you know what you're doing, but more than anything else, I hope you know that I care.